Let's move on towards question number 2A of 2013 Physics Optional UPSC. So the question 2A 2013 Physics Optional paper 1 says the following, that if the forces acting on a particle are conservative, so if the forces those which are acting on a particular particle, those are suppose conservative, so we have to show that the total energy of the particle, okay, after the given the fact that particles is having conservative forces acting on it, okay, so we have to show that the total energy of the particle is the sum of kinetic energy and potential energy. So you already know that total energy of a particle is the sum of kinetic and potential energies. So we have to show that kinetic energy plus potential energy, that is total energy, is conserved. That's what we have to show. And what is given to us? It is given that the forces are conservative which are acting on the particle. So let us see how to solve this particular question. So as conservative force is a central force, you already have learnt in the lectures, okay. So in the lectures I have already told you that conservative force is a central force. So conservative force, as it is a central force, so it acts in radial direction. So conservative force acts in radial direction, okay. So F equal to mass into AR. Now what is this AR? AR means radial acceleration. AR means radial acceleration, and M is the mass of the particle, and F is the force acting, and it is conservative force, okay. So you learn this particular fact in the lectures actually, that a conservative force is a central force actually, okay, and vice versa is also true. Central force is also conservative and conservative force is central force. This is what we learn in the lectures. So it acts in the radial direction actually, okay. And what is your radial direction? You can see over here that AR is the radial acceleration, okay. So radial direction means suppose we have some point O and there is a force acting, so the force will act either towards point O or away from point O, okay. So force will act in only two directions, that is either towards point O or away from point O. Then such a force is called a central force, okay. And in order to have the force to be conservative nature, okay, in order to have the conservative nature, the force must satisfy this particular property, that it must either act towards a point O or away from point O, okay. So that is the thing. So the force, the conservative force will be equal to mass into acceleration. Now acceleration will be radial, okay. AR means radial acceleration. Now formula for radial acceleration we have already learned in the lectures, that AR equal to R double dot minus R theta dot square, okay. AR means R double dot minus R theta dot square. You already have learned this in the lectures. The derivation of this particular formula, okay, the derivation of this particular formula, that AR equal to R double dot minus R theta dot square. This particular fact we learn in the lectures, okay. So in the lectures you will come to know, if you watch the lectures carefully. I have taught this particular fact to you, okay. So this is the thing. Now what does it mean by R double dot, by the way? R double dot simply means that we are taking derivative with respect to time 2 times, okay. So R double dot, what does it mean by R double dot? R double dot means d2r by dt2, okay, d2r by dt2. This is what is the meaning of R double dot. And what is the meaning of theta dot? Theta dot simply means that d theta by dt, that is the meaning of theta dot. And what is the meaning of R double dot? R double dot means d2r by dt2, okay. So this is the thing. So we have successfully written this particular fact. Now angular momentum of the particle. How the angular momentum is given? Angular momentum of a particle is given by J equal to mr square theta dot. Now from here theta dot will be equal to J by mr square, okay. Theta dot will be equal to J divided by mr square from here. How did we come to know this? Because this mr square will go in the denominator, okay. This mr square will go in the denominator and J by mr square will appear, and theta dot will be isolated from here. So theta dot equal to J by mr square, okay. So this is the angular momentum of the particle. Now this J is angular momentum, theta dot is d theta by dt, and it is equal to J by mr square actually. Now therefore F equal to m r double dot minus r. Now you can clearly have a look. Just substitute this theta dot value. This theta dot value you need to substitute over here, okay. So you will substitute this theta dot value in this particular expression. So what do you get then? You get some expression of this kind. You will get an expression of this kind. In the place of theta dot you will substitute J by mr square, okay. So this is the thing which you will get. So F of r equal to, this m will be multiplied inside, so m r double dot, okay. And what about J square by mr? So you can clearly have a look that m r double dot minus r J square divided by m square r to the power 4 will come. Then one r will be cancelled and it will be r cube, okay. So this is the thing. So you will get finally an expression of this kind which is shown to you over here. After you multiply this m inside this bracket, so one m will be cancelled from here So you will get this expression. So f of r equal to m r double dot minus j square by m r cube. Now how to understand this particular fact that we have to solve all these stuff like this? Okay, how do we understand? So in order to understand how to solve all this stuff, actually you need to practice a lot. You need to practice a lot, because all these things do not have any actually explanation. Okay, let me tell you that all these things which I am teaching you right now, they do not have any explanation. Okay, they do not have any explanation. You have to practice for UPSC physics optional. You have to just practice all this stuff. Okay, and after practice you will become a champion in all these things. After practice you will become a champion in all these things. So all these things actually do not have any logic associated with them. Okay, so f of r equal to m r double dot minus j square by m r cube. R double dot, what is r double dot? I have already told to you. Once again I am telling you, r double dot simply means d2r by dt2. Okay, means double differentiation with respect to time, double differentiation of radial vector, double differentiation of radial vector with respect to time. That is what is r double dot. Now if v of r be the potential energy of the particle, then what will happen? Suppose v of r is the potential energy of the particle, then f of r will be equal to minus dv by dr. Okay, because rate of change of potential with respect to not with respect to time but with respect to radius vector. Okay, radial vector. So f of r is equal to minus dv by dr, rate of change of potential with distance. Okay, that is what is force. Okay, radial force. So radial force is equal to minus dv by dr. Why is the force radial? Because the force is radial because it is conservative. Okay, because the force can be conservative only if it is central force, and if it is central force, then it will be radial in nature. Okay, so f of r will be equal to minus dv by dr. So what do you get then? So f of r equal to this much, you have already seen. F of r is equal to this much, you have already seen this. Now f of r again has an expression of this kind as well. Okay, so you will equate these two things, just equate this and this. Okay, so equating the left hand sides of both these equations, so what do you get then? So you get m r double dot minus j square by m r cube. What do you get? M r double dot minus j square by m r cube equal to minus dv by dr. Okay, so m r double dot will be kept as it is. So m r double dot has been kept as it is, and j square by m r cube will go to the right hand side. So minus d by dr derivative. Okay, minus d by dr of v plus j square by 2 m r square. Now when you actually differentiate this, when you differentiate this particular expression, you will get this particular expression. Okay, just have a look at this particular expression. Okay, and this particular expression, when you take its derivative, so you will get this particular thing actually. Okay, but how to remember all these mathematical steps? So the thing is, in order to remember all these mathematical steps, you need to practice a lot. Okay, there is no logic that how these things are coming actually. There is no logic behind this. Okay, for example, in maths, what do you do? In mathematics also, when you prove something, so it does not have any common sense type of thing. Okay, you have to remember the steps. Okay, you have to remember the steps sometimes. So that's why it is like this. So m r double dot equal to minus d by dr v plus j square by 2 m r square. So this is the thing. Now multiplying both sides by r dot. So we will multiply this side also by r dot and this side also by r dot. What do you get then? So m r double dot r dot equal to minus d by dr. So this expression once again we will write it as it is. So we have written as it is, and r dot we have multiplied. Now have a look at this particular expression. When you can clearly write it to be equal to d by dt of half m r dot square. Okay, this particular expression you can write it as d by dt of half m r dot square. You can yourself take the derivative and have a look. Okay, you can yourself take the derivative of this and have a look at it. Okay, let me tell you its derivative. Okay, so d by dt of half m r dot square. So what do you have? D by dt of half m r dot square. Okay, so half will come out of the bracket, right? So d by dt m r dot square. Okay, now m will again come out. So half m d by dt of r dot square. Okay, now what is r dot actually? So half m as it is, and d by dt, what is r dot? R dot is nothing but dr by dt. This is what is r dot. Okay, and it's square. So this is the thing. Then half m d by dt. Now we will not write d by dt over here. We will actually, this 2 will come in the forward. Okay, so 2 comes in the forward side, dr by dt, chain rule of differentiation. Chain rule of differentiation we are applying. So chain rule of differentiation you have applied successfully. Okay, now have a look at this particular thing, that dr by dt is r dot. Okay, this particular thing is r dot clearly, and this particular thing is r double dot clearly. Okay, and 2 will cancel from here. So what do you get finally? finally you get m r dot r double dot. Okay, so that is the thing. So that is the thing which has been shown. So m r dot r double dot equal to this much. Now just write this r dot as dr by dt. Just write this r dot as dr by dt, and this thing has been written as it is. So this dr and this dr, they are not cancelling actually, but you already know from the laws that suppose we have an expression of this kind. Suppose we have an expression of this kind. So what is it equal to? It is equal to actually dx by dz. It is equal to dx by dz. Now it is wrong to say that this expression and this expression cancel each other. Let me tell you very clearly. It is wrong to say that this expression and this expression these two dy cancel each other. It is wrong to say so. Why it is wrong to say so? See, 2 by 3 into 3 by 4 equal to 2 by 4. Okay, so these 3 and 3 have cancelled each other. This is correct. This is correct to say. This is correct to say, because all these are what? All these are numbers. 3 is number, 3 is number, 4 is number, 2 is number. So all these are numbers. So it is correct to say that 3 and 3 are cancelled and 2 by 4 is the final expression which we get. But over here, these are not numbers. Let me tell you, these are not numbers. This dy and this dy they are not numbers actually. They are what? They are differentials. They are not numbers. They are differentials. Okay, dy and dy are what? They are differentials. So as they are differentials, what will happen? As they are differentials, so we cannot say that they are cancelling each other. We cannot say that this dy and dy cancelled each other and so the final expression is dx by dz. It is wrong to say so. Okay, such things are asked in the UPSC interview. Let me tell you. Okay, if you have physics as an optional subject in UPSC, then such questions are asked to you in the interview. They will write an expression. They will write an expression in the interview that dx by dy into dy by dz, dx by dy into dy by dz. This is equal to dx by dz. Okay, they will write this and they will ask you whether this dy and dy have cancelled each other or not. So if your concepts are clear, you will clearly say. If your concepts are clear, then you will clearly say that this dy and dy cancel each other is a wrong concept. Okay, because dy is a differential, so we cannot say that they are cancelling each other. Okay, we can only say that dx by dy into dy by dz equal to dx by dz. This is what we can say, but we cannot say that this dy and this dy have cancelled each other. This is how you have to answer the question in the interview. Okay, now let me tell you, this particular thing we are imagining in our mind. Okay, in order to write the final expression of this particular entity, in order to write this final expression, it is just a coincidence. Okay, it is just a coincidence that it is appearing. Okay, it is just a coincidence that it is appearing that dy and dy are cancelled. It is appearing like that. It is just a coincidence. It is just a coincidence that dy and dy cancel each other, so final expression is like this. So this is actually a coincidence that whatever is appearing, okay, that is happening, but it is not the reality. This dy and dy do not cancel each other. Whereas in numbers 2 by 3 into 3 by 4 equal to 2 by 4, in numbers this is the reality. 3 and 3 cancel each other. Okay, so in numbers it is reality, but in differentials it is not a reality. So this is the thing. So do not write in the bracket, do not write such things in the bracket that this dr and this dr have cancelled each other. You cannot write such things in the bracket. Okay, you will lose the marks. You will lose the marks. So this dr and this dr do not cancel each other. Those are differentials actually. Okay, so we cannot say that this dr and this dr actually are cancelling each other. I have already told you. Okay, but in our mind while solving the expression, we imagine the wrong thing. For our convenience, we are imagining a wrong thing, that this thing and these things are cancelling each other. We are imagining in our mind. Why are we imagining such things in our mind? We are imagining such things in our mind because it makes us easy to solve the expression. But in reality, you must remember that this dr and this dr have not cancelled each other actually. Okay, it is just a coincidence that this dr and this dr are vanishing from here and it is becoming minus d by dt. It is just a coincidence. Okay, so these things you must remember for interview purpose. So minus d by dt, v plus j square by 2m r square. So this is the thing which we get finally. So you can have a look. Let me erase this particular slide and this particular slide. Okay, so what do you have? So dt is there, this dt is there, and again over here also it is dt. So just bring them together. So we have brought them together. We have successfully brought them together. So d by dt bracket, so that is we are applying the differentiation with respect to time function. We are applying on half m r dot square plus j square by 2 m r square plus v equal to 0. Okay, this is the thing. Now have a look at this particular expression. whenever derivative of something is equal to 0, have a look at this entire expression from here till here. Have a look at this entire expression from here till here. What is the thing? When we take its differentiation, it is coming out to be equal to 0. So this entire entity which I have marked over here inside the bracket, this entire entity must be a constant. Only then its differentiation will be 0. Okay, so differentiation will be 0 only if the entire entity inside the differentiation is constant. So this entity is constant. So we have written it. Now just write this j square. J is equal to m r square theta dot. We already know. So j equal to m r square theta dot we have substituted. So j square will be there. So square is again over here. And 2m r square is here. So 2m r square is here. So plus v is here. So equal to constant. So half m r dot square plus half m r square. Now this 1 by 2 will be over here. Okay. And this will be m square r to the power 4. What will it be equal to? This particular expression. Okay. M, let me write it with another color pen so that, so what is there? M square r power 4 theta dot square. Okay. And what is over here? 2m r square. Okay. So r square, and this will be r square. Okay. And what about this m? This will be m. Okay. So what is there? Half m r square theta dot square. So this is the expression which you get finally. So you can have a look over here. Okay. So half m r dot square plus half m r square theta dot square plus v equal to entire entity is equal to constant. So what to do next? So half m will be removed from here. Half m will be just taken outside. So inside the bracket what will be there? Inside the bracket r dot square plus r square theta dot square will be there. Okay. So r dot square plus r square theta dot square. So you can have you can write it to be r theta dot whole square plus v equal to constant. Now have a look at this. This is what? This is radial velocity. Vr square. R dot means what? It is Vr, radial velocity, and r theta dot is what? Transverse velocity. Okay. V theta is what? Transverse velocity, and r theta dot is transverse velocity. So we have written it. Plus v equal to constant. Now radial velocity square plus transverse velocity square. Radial velocity and transverse velocity are perpendicular to each other. Radial velocity v theta is transverse velocity and Vr is radial velocity. They are perpendicular to each other. So what is the, as they are perpendicular to each other, they are components of the velocity actually. Okay. So velocity v has two components. Velocity v has two components, which is radial component and transverse component. Okay. So when you square and add all these terms, so Vr square plus v theta square will be equal to v square. So Vr square plus v theta square equal to v square. You have written over here. Okay. Plus v is as it is and equal to constant. Now have a look at this. Half mv square is kinetic energy in classical physics. In classical physics, half mv square is kinetic energy, and v, what was v? V was your potential energy from the beginning itself. From the beginning itself, v was as it is. For a long time, v was as it is. So v is actually potential energy. So kinetic energy plus potential energy is equal to constant. Kinetic energy plus potential energy is equal to constant. And this is what we had to prove. This is what we had to prove. Have a look at the question. What was the question saying? The sum of kinetic energy and potential energy. Sum of kinetic energy and potential energies is conserved. This is what we had to prove, right? So have a look. Have a look. Kinetic energy plus potential energy is equal to constant. Okay. So this is the thing. So you have as they are constant, so we can say that they are conserved. Okay. Sum equal to constant means conserved. Okay. Sum equal to constant simply means that conserved. Okay. So in this way you can solve this particular question, which is question 2a. Okay. So from here, question 2a, physics optional 2013 paper 1 UPSC solved successfully. Now in the next class we will have a look at question 2b, subpart b. Question 2 subpart b will be solved in the next class. So till then have a look at the playlist which will appear over here. One playlist will appear over here. You have a look at that, and we can certainly have a goodbye.